projects.
Okay.
So,
1 minute, ma'am. Mercilin, ma'am, you can also record this, so we can able to upload it and show it to tags.
sir, already recording is in progress, right?
Yeah, recording is in
I'm doing
progress.
it from my mobile. I don't know how far it.
Okay, sir. If it stops, I will.
Yeah.
So students are having some doubts regarding that design part and all. So hope this session will be useful for them for further proceed, sir.
Okay. So let us start. We are starting with team 1, right?
Yes, sir.
So what I can possibly do is I can share the screen of the document that has been given by the team.
Okay, sir.
This is here in front of me. Is this the one?
Yes, sir.
Yes, sir.
Okay. So let me just start. I mean, if the team wants to ask me some questions in the beginning, I'm fine with that. Or if they want me to go ahead and then they want to come with their questions, that is also fine. What is the order you want to follow?
Sir, if team if they have query means they will ask after that.
Okay. So does this team have any questions to ask me? Or I can go ahead and review what you have given.
Team 1.
Sir, you can go ahead, sir.
Okay.
Okay. So I'm only trying to review the methodology that you have all followed in relation to what we had discussed as the preferred methodology when I gave you the lecture. And of course, my lecture happened much after you had already progressed a long way in the thing that you were doing. But I just wanted you to step back as if you were going to do it afresh and then try to cast the nature of your work in the framework of this methodology. So in that spirit, let me now review what I'm seeing in front of me. Are you all able to see the screen, the text Word document?
Yes, sir.
Yes, sir.
Okay, good. So the first thing I had said is problem statement. So when we say problem statement, we should actually describe a problem faced by someone without trying to guess what the solution must be. It must be a pure description of a problem. Like I had said in my lecture that somebody has a broken back. He has to lie flat on the bed, but he has to continue to work on a laptop. Or I think there was another problem described about fumes in a kitchen, which make it very uncomfortable for a lady who is working. Is that right? Was that the problem that we discussed in our lecture?
Yes, sir.
Okay. I don't remember what all problems we discussed, because I have given in 2-3 venues this kind of thing. I think in some other place, the problem that people came up with was a working woman traveling probably on a two-wheeler or in a public transport, needs to carry office files and laptop and probably mobile and other things. And existing solutions are very inconvenient, uncomfortable. They crumple a sari and things like that. So what's a good, and also it causes backache for the working woman. So like this, there are different problems. Now, when we talk of a problem, we talk about a person who is facing a problem. So in that context, if I were to look at this, here there is a description about a thing, about a wind turbine. We are not talking about a problem faced by an individual, or a group of people or whatever. We are directly talking about an object. Now, taking an object and improving some aspect of an object is what I may call as an engineering activity. It's not a design activity. For example, if I'm working in a big multinational company and they are making some, let us say they're using some alloy of aluminum to make some valves. I'm just imagining some scenario. Okay. And that alloy and the component that's being made, these are all expensive things. So if I'm an engineer working in that company, my boss will come and say that, now I want you to reduce the weight by 5% so that we save 5% of the material, but its performance must not be affected. And what is the performance? Some force and some pressure and whatever it has to withstand. So this is a routine engineering activity, which some specialist engineer with some experience in the domain will be able to do. But this is not a problem solving activity. Design is about solving problems. So from that point of view, we are actually jumping into a bladeless wind turbine. And my first question will be, why do we even need a bladeless wind turbine? Who needs it? What problem of theirs will it solve? Okay. Why can't that person live happily without a bladeless wind turbine? So let us start from that. So team one, any of you can respond.
Sir, actually, traditional wind turbine, it's like very huge in size, sir, and it requires
No, that is all right. I'm sure that there is an object that can be improved with engineering. Almost anything that we see around, we can improve it. You can see a notice board behind me. I can tell somebody improve it. They can improve it in some way or the other. That's not what we are trying to do here. We are trying to identify somebody having a problem, and then we are trying to find out a way in which that problem can be solved. So who is facing what problem is the problem statement.
Sir, actually, this bladeless wind turbine can be used in for domestic purpose, sir. But whereas the traditional one can't be used for domestic ones, sir. It is usually right now used under only industrial purpose.
Wait. What is the use of a bladeless wind turbine, and who needs it? Let us start from there.
Sir, it is very useful for someone who is living far away from the city, sir, and he's not able to afford, he's not able to get the supply of current, so he can able to generate his own current by using our bladeless wind turbine, sir. So it will be very useful for them.
So let us not start with the bladeless wind turbine. We must start by saying that there are people who are outside the electricity grid and they need electricity. That is the problem statement. Is that correct?
Yes, sir.
Okay. So maybe you can take notes as we discuss. I'm redefining the problem statement as people outside the grid, electricity grid, need electricity. Fine. That's the problem statement. Fine.
Yes, sir.
So if everybody in the team agrees with me, we can move further. If anybody has wants to contradict me or modify what I'm saying, alter what I'm saying, you're free to speak up. All are agreed with this? Okay. Now, people outside the grid need electricity is a reasonably vague statement. As we discussed, the problem statement must be defined as sharply as is possible. So when we talk about people outside the grid need electricity, we must say, what do they need electricity for? Because that will help us know whether they need 100 watts of electricity, or do they need 1 kilowatt of electricity? Do they need 1 megawatt of electricity? What is the purpose for which they need electricity? What do they need electricity for?
Sir,
So
nowadays,
for-
Yeah, go ahead. Feel free to talk. Feel free. Say whatever comes to your mind. No problem.
Sir, actually for domestic purpose, sir, like someone in village cannot afford to have hot water or something like a washing machine. So for them, having electricity can be very useful, sir. So that it will save their times too, sir, because a lot of outside city grid people are mostly involved in agricultural activities. So for them, having this kind of energy would be very useful for them, sir.
So this is fine. So you are trying to provide the domestic electricity requirement needed by a typical farmer. Would that be a good way to put it?
Yes, sir.
Okay. Because a farmer may need electricity on the field also for irrigation and things like that. But that is not what we are trying to do. We can always define what we want to do. You have to be clear about the problem statement. Are you trying to provide water for irrigation if it's a farmer? Or are you trying to provide electricity for domestic use?
Sir, for both, we are trying, sir.
Okay. So you want to provide electricity for domestic use as well as electricity for the farm. For the farm, mainly it will be for pumping water for irrigation.
Yes, sir.
Okay. So that's good. So instead of saying people outside the grid, let me say farmers. Farmers who are outside the grid, they need electricity. Would that be a good problem statement?
Yes, sir.
Okay. And they need electricity for the farm and they need for home. Okay. Is that a good definition?
Yes, sir.
Good
Yes, sir.
description. Okay. So this gives me some idea about the kind of farmer we are talking about. See, I don't know how many of you are aware. Do you know what percentage of houses in India are outside of the grid? Does anybody know what percentage of households in India do not have access to the grid?
sir, around 20%, sir.
Around 20%. How did you get that number?
Recently, I studied about it, sir.
Are you sure?
No, sir, doubtedly.
Hmm? You don't know for sure. I'm just trying to do a quick check. Grid coverage in India. Or let me say grid. Okay, so I'm saying that 13% of Indian households don't have access to grid. Okay. This is what I'm seeing when I just Google saying households not covered by grid coverage in India. Okay. And this is dated end of 2020. So it's not very old, a little more than a year old. Fine. So 87% of the people have access to electricity. And so 13% either use non-grid sources of electricity or don't use any electricity at all. And Okay, this they're talking about population, but when it comes to households, only 4% of households do not have access to grid-based electricity. Fine. These are the numbers. Do you want me to share the screen? Let me stop share and again share this. So this is the picture. Are you all able to see this?
Yes,
so
sir.
the headline says 13% of households, and but in the text they say only 4% of the households do not have access to grid-based electricity.
We have close to 290 offices.
But a number of agricultural customers, which means farms, about half of the farms do not have access to electricity. And it also says that India has achieved 100% connection rate for all the willing households. Means whoever asks is being given. Only people who didn't ask are not given. Okay. So anyway, now we can actually do more study on all these things and go on. I'm not trying to do an R&D now in this call. What I'm saying is we have to spend a lot of time describing the problem properly. So supposing we say that we are targeting farmers who are outside the coverage of grid for their home and farm. We should understand that farm is a very different cup of tea compared to home. Home may require very small amount of electricity. The power required is very little, the home, but the farm would require a very heavy power electricity. On the other hand, the farm will require the electricity only for a short period of time. Maybe a couple of hours, 3 hours when it needs to be pumping. And whereas the home may require electricity for different purposes at different times of the day. So there will be some usage pattern and things like that. So now when you are talking about providing a solution for somebody who is outside the grid, all these things will become important because you have to look at what is the amount of power that should be supplied to one house, and what will be the cost of the equipment needed to supply that power, and is there any seasonality about the power? Supposing the power is available at a certain time of the day, but the requirement of power is at some other time of the day, then they cannot use it. For example, if I have a solar panel, but I need the power at night, then I cannot use the solar panel. Otherwise, I have to provide the solar panel along with a lot of batteries, with which they can store. And that may make it very expensive. So like this, there are many things that we have to consider before we even jump into the bladeless wind turbine design. Understand?
Yes, sir.
So we have to do in this first paragraph, we should not even be talking about the bladeless wind turbine. We must be describing the problem in reasonable clarity. And then we come to the before-after scenario, where we say that even in this before-after scenario, we are not talking about we should not be talking about a bladeless wind turbine. That must come in the end. We must say that if the electricity is provided, then what will be the impact? The impact is that their household income may become threefold, and children will be able to study at night. Maybe like there's so many things. That's the before and after scenario that we're talking about. Okay. And then we are describing the user. So the user is somebody who says, I like your thing, I'm willing to buy it, and I will pay for it. That's the user. Okay. So what is that kind of user? How old is that person? How much is that person earning? What kind of a house does he or she live in? How many people live in that house? And if you're providing a solution for the household, then how many people will be requiring that, will be using that solution in the household of that person? And what are all the purposes for which they will be using? And they'll all be using it at different times of the day. And will they be using it in the same way throughout the year, or during a certain season they'll be using more, in some other season they'll be using less? Is there any cyclicity in it? All this can be described in greater detail when we describe the user. And we can of course talk about the farm. Will that person be having a half-acre farm? Will the person be having a 10-acre farm? What will that kind of person be growing? If the person is, for example, growing rice, then they're likely to be in a fairly well-irrigated, fertile area. So they will not be outside the grid. And if we are talking about some remote, hilly locations where there is no grid, probably they are not even growing rice. They will be growing what are called dryland crops. What are called millets. Millets na sirudhaniyam. Things like ragi, kamba, etc. So then they probably don't need irrigation. So all this will have to be described here when we are describing the user. We must be able to create a portrait. Portrait na theriyuma oru varaipadam madri. We have to create a full picture of the user here. And here also we are not talking about the actual solution. We are not talking about the wind turbine. And simply bundling here, saying that it can also be used in urban areas, it can also be used by tribal people, shows that we have no picture about who the user is. You can't have one solution that is simultaneously designed for tribal people in a dense forest and urban areas. Okay. In fact, in urban area, the people will have no land. They'll be living in some very small shared accommodation. There'll be no land at all. Especially people who cannot afford to pay electricity will be living in very, very cramped accommodation, crowded areas. So if we start by describing the urban user, we may find that they have no place to put a turbine. So let me remove urban area user as a category, because it won't even be applicable in my opinion. So yeah, the constraints are like what we just now discussed. If you're targeting an urban person who cannot afford to pay electricity bill, so typically I think domestic electricity bill lowest slab will probably be about 300 rupees a month. Okay. But if a person cannot afford for a family to pay 300 rupees a month, which means about 10 rupees a day, then it means they are really in very poor shape, and they will not be able to afford to buy a turbine. They will not even have the land to put up the turbine. So they will be in some multi-story tenement where they are occupying one corner, which is having some one room and a small kitchen in a corner and that kind of a thing. So these will be the constraints.
Actually, it is like right now nowadays many people are affording for solar panels, even though it costs like over 3 to 4 lakhs, sir. So it is alternative to like installing a solar panel. We are trying to give it a try at terrace, sir. So it will be useful for them for bringing down the electricity bill, sir, in urban areas.
Okay, then you have to describe that user properly. And whatever solution you are building for an urban user who can otherwise use a solar panel, that kind of a solution may not be applicable for a tribal person in a dense forest. So all these things will have to get described and fleshed out properly without jumping to a solution. Otherwise, it will be like a solution in search of a problem. We first decide that we are going to make a turbine, and then we are trying to see where all it can be fitted. So that is the inversion of the problem. We have to start with a problem and come to a solution, not start with a solution and then define a problem. That's all I'm saying.
Okay, sir.
And so if you are talking about an urban user who is thinking of putting a solar panel on his rooftop, then if we eventually come to a to identify that this wind turbine is a solution, then we should be able to say why the person will choose the wind turbine instead of choosing a solar panel. Because solar panels are fairly well established. They have a lot of subsidies from government. And if I produce electricity and I'm not using it immediately, then I can put it back in the grid and the government will pay me for the electricity. All kinds of things are well worked out. Now, in that kind of a context, why will that person not like the solar and instead choose to have the wind turbine? Will be the question to be answered. So anyway, I'm just giving this as a flavor to say how we should think. We should not, our thinking should not be solution centric. The center of our thinking must not be the solution that we're going to work on. The center must be the problem that we're trying to solve. We should have problem centric thinking, not solution centric thinking. So this is basically the flavor. And again, when we come to the section called pass or fail, you are able to see the screen, I suppose, correct?
Yes, sir.
Yeah. So here also, what we mean by pass or fail is, if we give the solution in the hands of a user, we don't even know what solution we're going to give. We don't know whether we're going to give the person a solar panel or a wind turbine or anything else. Okay, we may just give a generator coupled with a cycle. Then the person can pedal and generate electricity. There are so many solutions possible. We don't know yet what we are going to give. But when we give the person a solution, that person will either like it and accept it, or the person will dislike it and reject it. So we are trying to list, without yet guessing what the solution is, we are trying to guess what will make the user like the solution and accept it, and what will make the user reject it. Those are the criteria that we are writing down. That's what should come in this section. Whereas this is also about the thing that we are building, because all along we have already frozen on a thing. Our thinking is very, very solution centric. So till now, our thinking should be completely problem centric. And after all this thinking has been done, that is after which we come to the solution architecture. And we may find that if we have done all this thinking properly and systematically, we may find that some other solution than the wind turbine is what is best suited. We may find, I'm not saying we will, we don't know yet. Okay. So that's the exercise I wanted you to do. And then of course you have described the blocks. This is all fine. Project plan should be done in greater detail because it's very vague, producing necessary materials. There may be a long list of materials, but what are the important things which can go wrong? Or what are the important things that will be too expensive? Or what are the important things that will take a long time to come? All that should come here, okay, in the project plan. All the things that are critical to success should be described in the project plan in detail. Because what you have written here is very general. We have to make the materials, we have to assemble the setup, and then we have to present the final prototype. But that is just very generic. This will be true of any project. It's not specific. Here, specific to our thing, oh, I need one particular sensor, and this sensor is not available anywhere in the world except Sweden, and it's going to take 3 months to come. It is going to cost 2 lakh rupees. Then it's a very difficult thing, or whatever. So all those kind of critical things should come. But the criticality may be because what we get will not meet the quality that we expect, or what we get may take a long time to come. Then it will delay the whole project. Or it may be critical because it is too expensive, it's too costly. So all those things should get listed here. So once all of this is done, of course, what you have done here is perfectly right. You're doing the detailed design. It's not sufficiently detailed yet. You have to go into a lot more details. But yeah, all those details will be needed for you to make the product. So this is all that I wanted to say. And I have taken a little long time in reviewing this because for the subsequent teams, I'll be reviewing in a similar style just to see whether the methodology is aligned with what we have discussed or not. So ask me any questions, otherwise we can move on to the next presentation. Are we fine with this?
Yes, sir.
Okay, I'm just trying to share the other one. Just a moment. So I will go to the team 2.docx and share it right away. What I would like the other teams to now do is that I don't want to talk much. I have given you a flavor. And what is the name of this document? Team 2. Okay. I would like the teams to do more of the talking. So here we are talking about alternative method for energy harvesting. So how will we rewrite this? We are not talking about energy harvesting or anything. We are talking about a problem that some person is facing, which we are going to solve. So how will you reword this? What problem is somebody facing, which we will solve? Before after scenario is how will their life improve after the problem is solved? So can the team 2 talk about this in that line, in that way?
Sir, we are trying to develop a energy harvesting machine from the piece of
Your voice is breaking a little bit. It's not clear. Maybe you're a little far away from the mic.
Sir, for energy conservation, sir, we are developing a model for harvesting the energy from the piezoelectric cells.
I know, but that's an object. That's a solution. I'm asking you to describe the problem that you're solving. What problem are you trying to solve?
The energy works in the punch bag should be converted in another form of energy to use in our smartphone.
The energy?
Wasted in the punch bag, sir.
No, that is what the thing will do. See, somebody is facing some problem in their life. What is that problem? And who is that person? This is what we should talk about. Who is the person facing a problem and what problem are they facing? See, being a designer is like being a doctor. First, a patient has to come and say, I'm having a problem. My stomach is aching. Then the doctor will ask many questions. Where is it aching? In the upper right half it is aching. Is it aching all the time? No, about half an hour after I eat, I get a lot of ache and then It is there for 1 hour and then it goes away. Like this, there will be many questions asked about the problem. A pharmaceutical company will be making drugs for various purposes. Randomly, they will make. Okay, they'll keep on trying to invent drugs. But that's not the job of a doctor. The job of a doctor is not to pick up some drug and then give it to whoever comes in. The doctor will spend more time asking a patient what your problem is. So being a design engineer is like being a doctor. Somebody is having a problem. What is the problem? Who is facing the problem? And then some more details about the nature of the problem being faced, and some more details about the nature of the person facing the problem. Only in the end we come to the medicine. Right? So try to describe the problem that you're solving. And the problem is not a problem if nobody in the world faces it. Somebody should be facing the problem. So along with the problem, you have to also say who is facing the problem. Maybe you want to think a little bit more about it and then come back. We'll go on to the next. I'm just trying to get you all to think along those lines. We'll go on to the next one. We can then come back to whichever team wants to then review.
Sir, actually, we didn't take any particular base for a problem, sir. We just tried to make a prototype that maybe it will be big for some other
I know
time.
it. I'm not asking you to not make it. Don't get me wrong. In fact, when I came there and talked to you all, I said, you've already done 80% of your work before I could give you a lecture. But I'm asking you to recast the same work that you are doing. I'm asking you to recast it in a different way. I'm not asking you to change what you're doing.
Yes.
You recast it in a different way, which offers a strong justification for whatever you're already doing.
Yes.
Okay. Don't change what you're doing. Please go ahead and do it. You already invested a lot of time and effort in it. And it is good work that you're all doing. I'm not questioning that. I'm saying you recast the nature of the work in the language of design. I think this is the problem I'm going to solve, for which I'm doing a design. So this one seems like a easier problem to cast in that framework. The problem statement is, are you all able to see the Steam 3's document? I've shared it.
Yes, sir.
So here we are saying to rescue a person from a fire-filled room and surveillance of the victim to reduce risk using a rover robot. I think this is a good problem statement, and it will need to be elaborated a little more. So we have to say whether we are talking about something for a house or something for a mall, something for a cinema theater, something for a place where a function is happening like a marriage hall. What kind of context are we talking about? So a little bit more elaboration on the nature of the problem that will be solved.
Sir, in multi-story building, sir.
Oh, this is in a multi-storied building. Okay.
The
So
fire accidents caused due to the short circuiting, overloading, like that, or
Okay.
leakage of gas.
Okay. Fine. So that should come in the problem statement. To rescue people in a multi-storied apartment when a fire breaks out. So we are talking about residential, or we are talking about commercial also. Supposing it's a multi-storied mall, 4 stories of mall is there, and then there is a fire. Is our solution going to address that also, or only houses? Is somebody trying to talk?
Sorry,
I'm
sir.
not able to hear. Yeah.
Sorry, sir. I can't get you. Can you repeat it?
No, my question is our solution meant for a multi-storied residential apartment?
Yes.
Or is it going to also address crowded places like multi-storied malls and things like that? If there is a 4-storied mall and there are thousands of people there, and then suddenly there is a fire. In that kind of context also, this will work, or it is meant for saving one individual at a time?
It is used in multi-story building, and it can be used in malls also, sir.
Okay, fine. So, so the before-after scenario will be that it's not about before entering the room or after. Before the solution is made available, and after the solution is made available. That's the meaning of the word before-after. So, before the solution is made available is today's scenario. Today, if a fire breaks out, what do people do? They maybe some fire alarm goes off and people come running down the stairs, and then they find that when they come down one floor, there is a big fire. They cannot go any more down, and they have nowhere to run. Okay, this is the problem. So they are stuck where they are, and they will either get burnt or they will die by inhaling carbon monoxide. Something like this will happen. And unless a firefighter comes and pulls them out, maybe in the next 5 minutes, then they will not survive. Something like this is the before scenario. Then the after scenario is when we make our solution available, what will happen? How will the same kind of incident, how will this drama be played out differently when our solution is available? Again, the alarm will go, the fire will happen, the alarm will go. After that, what will happen? How will our solution act? Is what should be described in the before-after scenario. And then who is the user? So again, user is a very broad word. User can mean the person who pays and purchases it from you. User may be the person who is actually handling the equipment. So if you're talking about a multi-storied building, for example, maybe the person who is building the apartment may purchase this equipment from you. And then he hands over the buildings to the people who are occupying. All the common facilities he will hand over to the Residents Association. And along with it, he will also hand over this robot and go away. So he is the person who purchased, but he is not going to be using the equipment.
Firefighter, sir.
Okay. Oh, the firefighter will be coming in the fire engine along with this rover that you are having. Is that right?
No, sir. It's like if the firefighters don't have the way to extinguish fire, we just can move on with our design, sir.
Very nice. Fine. So you describe that. Then the user is the trained firefighter.
Yeah.
Correct?
Yes, sir.
Okay. So that changes the thing. If I was thinking that an ordinary person who is there may have to use it, in which case it will be very difficult because you may have to specially train the person, etc., to handle your thing. But yeah, if you're saying it's a trained firefighter, then that firefighter can be trained on how to use this. No problem. So the user will be the firefighter. That's a good way to define it. No problem. So that is what you should write here. The user is a professional firefighter who will be trained to use the equipment. So that's good. And the constraints means the constraints within which the thing will be used. The rover must be something which the firefighter is able to easily bring, along with all the other things in the fire engine. He's bringing the fire truck with a lot of water and other things. Along with it, he must be able to put this rover also. It must not be so heavy and unwieldy that he cannot put it in. So it means it must be something which can be packed neatly, picked up, brought in the truck, and then it can be unopened and deployed very quickly. Those are the constraints. Fine.
Yes, sir.
So you can describe those things. You can say it must not weigh more than so much. It must not be bigger than this much size. It must be able to carry so much of load. All those things can get described in the constraints. Fine.
Yeah, we can. We are having an idea about it, sir.
Sure, I'm
About
sure you
our-
have an idea. I'm asking you to put that in the document. That's what this document needs.
Okay, sir. Next time we will
Fine.
do, sir.
And then the pass or fail criteria. It must be stable. It must not topple and fall when it is bringing a person. And it may not be bringing the person on a level road. It may be bringing the person down the staircase. It may have to get in through a window. Like this, there will be very many requirements which a firefighter will ask before saying, okay, this is nice, I will take it. Right?
Yes, sir. We just did a prototype model, sir. We just tested, and it was and our result was positive, sir. So
Very good. Very
I think,
good. So when you say it is positive, it means you have scored 100% marks or close to 100% marks. That's the meaning of a positive design. I am telling you, you write the question paper. You have already written the answer, which is the drawing I'm seeing here. But
yes.
how much marks should you get will be dependent on the question paper that you write here. That is the pass or fail. So you write 5 or 6 things. Then against those 5, 6 things, when your solution is evaluated, you have got 95% marks.
Okay, sir.
Okay. So this is all fine. I'm not getting into the specifics of any design, if you notice. I'm only trying to align whatever you're doing with the methodology that we discussed. Then, yeah, you're going into the building blocks, project plan. Again, your project plan is lacking in detail. It is very broad. Purchase materials, do a calculation, test. It has to be more specific. It has to be specific to actually tell the team members what are the things they should be mindful of. What are the things that can go wrong, which they should be alert about, watchful for. So that is what this is. So this is also over. Let me stop sharing this and go on to the next. Team 4.
Sir, one doubt, sir.
Yeah.
Sir, I'm from team 2, sir. You told about a problem statement, no, sir. Like we are planning about there are many waste energies are there, no, sir. Like we are doing when we do any mechanical work means many energies are going waste, no, sir. So that energy we are converting into an useful electrical energy, sir. We are converting into an useful one, sir. That waste energy to an useful one we are making, sir. So like that we are thinking, sir. So to produce a sustainable electricity, sir, by not burning by eco-friendly manner, sir.
Okay, so let me see how to then word it as a problem statement.
Yes.
The problem statement could be that so
to an useful one, sir, to useful electrical energy, sir. The waste, if a vehicle are going in a speed breaker means like many energies are going waste, no, sir. So we are converting like that. We are converting that energy to an useful one, sir. Waste energies. Like if a boxer punches the bag means it goes waste only, no, sir. His energy will go waste only. So we are converting that energy to an useful one, sir. Like that we thought, sir.
This is fine. See, somebody should say, this is nice. This is solving some problem of mine. I am willing to pay you money for this. Who will be that? And what will be that problem?
Sir, I couldn't what, sir?
See, whatever you build.
The exercise, who are exercising in the gym, sir, and the kickboxing professionals can use it, sir.
So, see, somebody must say that you have built something wonderful. I'm willing to pay you 1,000 rupees, 1 lakh rupees, whatever it may cost. because this is solving some problem I'm facing in my life, and it is going to improve my quality of life. So what is the price? Here it is. I'm willing to pay you that money. Who is that person and what is the problem?
The sports centers may acquire this product, sir. Like instead of depending on some other source for their energy, like for electricity, they might use this one as an alternative, sir. So this
Okay.
would
So let us say a gym. A gym is the
yes,
user.
so they may have a target audience.
And supposing you say that a gym is using some amount of power every day, but the people who come there to work out are also spending a lot of time when they work out, a lot of energy when they work out. And if we can recover that, then the power consumption of the gym will come down by 30%. I'm just saying.
Yes, sir.
Okay. And this is the problem that you're trying to solve.
Yes, sir.
Would that be correct?
Yes, sir.
Yes,
Very
sir.
nice.
That's the
Yeah.
way we are.
So whether it's a treadmill or whether it's a punching bag or whether it is some ladder they are trying to climb or some weight they are trying to lift. Just a moment. All of those, all that energy can be recovered. Are you trying to recover only one type of energy like a punching bag, or it can be your solution? You're trying to solve all these energies.
Only one type of energy.
Only one type of energy, the punching bag.
Yes, sir.
Okay. So you must, supposing you go to a gym owner, and have you any idea how much of energy in terms of units? We measure electrical energy in terms of units, no? Kilowatt hours.
Yes, sir.
So how many units of energy in a day will you recover through the punching bag? Have you any idea?
It's enough to power charge the smartphones and the emergency lights. That's why.
No, tell me in kilowatt hours. How much? How many kilowatt hour does it take to fully charge a drained out mobile phone? Have you any idea?
About 4,000 to 5,000 mAh.
4,000
to 5,000 mAh, milliamperes.
No, I'm telling you in kilowatt hour. 1 kilowatt hour is 1 unit. So you are saying it is 4,000 milliampere hour. That is current. Into hours, that means actually so many coulombs of charge. But what is the energy? See, typically it will be 5 volts. So if we say 4,000 milliampere hour, it's the same as saying 4 ampere hour. 4 ampere hour into 5 volts. Amperes into volts is watts. So 20 watt hour. So 20 watt hour is 1 kilowatt hour is 1000 watt hour. Okay. So when I say 20 watt hour, I am talking about 1 by 50th. I'm talking about 2%. 2% of a kilowatt hour.
Yes, sir.
Correct? And what is the cost of 1 kilowatt hour?
About 7 or 5 rupees, depends on what you use.
Yeah, typically houses it will be 5 rupees, and then if it is industrial or something, it will be a little bit more, 7 rupees something. So anyway, for ease of division, let us take it as multiplication division. We'll take it as 5 rupees. So 2% of 5 rupees. 5 rupees is 500 paisa. So 1% is 5 paisa and 2% is 10 paisa. So one cell phone requires 10 paisa worth of electricity. Is that fine?
Yes, sir. That's fine.
10 paisa because it requires 20 watt hours of energy. Now, your punching bag will generate enough power to in a day to charge how many cell phones?
2 or 3, sir. Two
or three.
phones are- Yes,
Okay.
sir.
So that means the worth of whatever you build will be 30 paisa per day. If it is 3 cell phones. So 30 paisa into 30 days is how much? 900, 9 rupees.
9 rupees.
Okay. So whatever you build is an equipment that will help the gym to save 9 rupees in a month. Okay. So if you are giving something which will save 9 rupees in a month, then how much will the person be willing to pay you?
Uh, 500 or 1,000 maybe.
Supposing I ask you to give me 1,000 rupees, I'm a bank. I'm asking you to deposit 1,000 rupees with me, and I'll give you 10 rupees every month. Will you agree?
100. That's a huge time to repay that.
So yeah, provided at the end of it, I'm also giving back the 1,000 rupees to you. Maybe after a year. Then you can say that you got 100 rupees or 120 rupees from me. Then you got 12% as interest, and then I'm giving you back the 1,000 rupees. So 1,000 rupees is a fair deal. But when you are giving the person an equipment, then at the end of 1 year after he has saved 10 rupees every month, if he says, here is your equipment, take it back and give me back my money, are you going to give it back to him? No. Right? So then you will have to reckon it somewhat differently. But anyway, for now, let us assume that 1,000 rupees. And by installing something for 1,000 rupees, the person will be saving 10 rupees every month, which amounts to 120 rupees in a year, and that will translate into an annual return of 12%. So that is fine. So these are the kind of things that we should be describing in the document. Okay, I'm not right now going into is it correct, is it wrong, or anything like that, because there's nothing called a correct answer. I already told you. It all depends on your definitions. So I am asking you to define the problem. So rather than saying to find an alternative method of energy harvesting or something, you start off by saying there is a gym, and the gym has a option of capturing the energy wasted on the punching bags, and the energy so saved can be used for any other productive purpose. This is the objective. And then you can go through the rest of the exercise as we discussed. Is that fine?
Yes, sure, sir. We will modify it as you said.
Huh? I couldn't hear you.
Sir, we will modify like as you said, sir.
Yeah, yeah. Fine. So then I'm going to the next one, which let me share. Yeah, probably running out of time. I'll go a little bit faster, but feel free to stop me. So this one is fluorophonics based plantations. So see, again, here we are talking about an indigenous crop, precise amount of water, mass production. So it's all about things. We have to start with the person. We have to start with the person who is facing a problem, and describe the problem being faced, and then say, if you give a solution, how will their life improve? That person. But there's no description of the person over here. Okay. So things like India, sunlight, all these are general. We are talking about people. We are talking about people facing problems, and we are going to solve their problems. Okay. We are like doctors for the general life problems that people face. Doctor will solve the health problems. We are trying to solve life problems through engineering. So we have to start with the patient. Okay, he's an engineering patient. We know engineering, we know design, we can cure people of their problems. That's the way we have to think. And so then once you start off like that, the entire flow of this will be very different. Okay. So I'm not saying change what you're doing. The content of the project you're doing need not be changed, but try to fit it into the lives of people. Otherwise, you will build something which nobody needs. Fine. So I know about this project, so I'm not going into the specific technical details of the project, which is all fine. And let me go to project number 5 also before we run out of time. Hand washing dispenser. Okay, so here we are starting with places where bathrooms are used by a large number of people. So it's a fairly well identified, the problem identification is correct, and solid wastes are huge. Now, I don't see where solid waste is getting addressed by hand washing dispenser. Because hand washing is not going to address the problem of solid waste. So probably this bullet point is outside the scope of this project. We are talking about hand washing and how to reduce the usage of water in hand washing.
So,
yeah.
Is it audible?
Yeah.
So when we in corporate sector, they often use tissue papers, sir. So
okay.
the wastage of tissue papers it's solid waste, sir. So to reduce that, we are using a hand dryer. So the solid waste also is.
So then let us be specific. The problem statement should be as precise as possible. You say that a huge amount of tissue paper is also used after hand washing. Make it very specific, because solid waste is a very wide category.
Okay, sir.
So tissue paper is one of those, which is what you're addressing. So make it very precise. Fine.
Okay, sir.
So otherwise, yeah, this is good. The statement of the problem is precise. Okay. And the before-after scenario. Before-after scenario is, before you give any solution that you're planning to give, you can say that a typical restaurant is using in a day 100 liters of water for hand washing. And after I give my solution, only 10 liters will be used. Okay, that could be one way. And apart from using 100 liters of water, they are using 2000 tissue papers, whereas no tissue paper will be used and only 10 liter water will be used after. That is the before and after scenario. Okay.
Sir, this actually, sir.
Yeah, tell me.
So in describing the after scenario, you told to not describe the solution first, sir. So how can we describe the after scenario without directly addressing the solution?
So
like we are halfway through the
see you are not describing the solution, you are describing the target. See, supposing I say, I want to make a car with which I will be able to travel from Chennai to Coimbatore in 5 hours, and it should be able to accommodate, apart from me, the driver, 4 more people. So traveling with 4 more people along with me, I must be able to travel from Chennai to Coimbatore in 5 hours. Supposing I'm just describing this as my after scenario. It does not mean I have designed the vehicle. It may be a very powerful car. It could be a little aeroplane. I don't know what. I have not frozen what I'm going to do. I'm only saying that with 4 more people with me, if I start from Chennai, I should reach Coimbatore. That's all I'm saying. In 5 hours, 4 hours or 5 hours, whatever. So this is the target. The design is a way of achieving the target. Is that clear?
Okay.
What I'm saying?
Yes, sir. Yes,
So you set a goal. You say that I want, supposing you say that the restaurant that is using 100 liters of water will, after my solution comes, will only use 90 liters of water. That is also valid. You are saving 10 liters of water. And you are probably saving 2000 tissue papers. That may also be good. But what is your target? You should be having clarity. And that clarity doesn't come actually from you. It comes from your understanding of the end user. Will the end user be happy if you say I'm saving you 10% of water? Or will he be happy only if you say I'm saving you 90%? What is it that the person expects? Or what will that person be willing to pay? Because you also may have a vague idea that unless I get paid at least 10,000 rupees, I should not do this. So what will make him pay 10,000 rupees to me? So in different ways, you should have a target. If I'm going to play, let us say, a game of cricket, I'm the captain of the team. I'll say, okay, boys, we are all now going to play 20 overs. We must try to achieve a score not less than 200. I'm setting a target. I don't know whether I'm going to hit all sixers or whether I'm going to score 2 runs in every ball. I don't know how I will do it. I don't know how many wickets I will lose. All the details I don't know, but this is a target. Because broadly, I know that this is the kind of team, when they come and play, and if I bowl to them, unless I have 200 runs on my scorecard, I cannot defend the score, I cannot win the match. So that's the target. Okay. What does it take for you to win the match? That is the after scenario. It's not the details of the design. And yeah, typical user, I think you have described it well. People in all age groups. And what are the constraints? So what you have written here are probably, I'm not saying they are incorrect, but they are not specific enough. Supposing you are taking a solution to a restaurant or a mall or somewhere, looking at it, he will say, this is very nice, I'll take it. Or he will say, I don't like it. Or he will accept it only if it meets certain constraints. What are the important ones in this case? For example, if your thing is going to take power, will your solution be consuming power? Whatever solution you offer, it will be consuming power. Then it should not take 1 megawatt of power. Okay, because the hotel does not have a 1 megawatt connection. So you must try to say that I'll give a solution where the power is less than 1 kilowatt. 1 kilowatt is 1000 watts. Okay, something like that. That's a constraint. Its physical size should not be more than something, because they won't have place to keep it. I cannot say give an entire room for me to keep my equipment. It must be something which can be put on the wall, like a hot water geyser, maybe. So it must not be of size and weight more than a normal bathroom geyser. Maybe that's a constraint. So you can define whatever you think are relevant. I'm just helping you to think. I'm not saying what I'm saying is correct. These are the kind of things that will come in constraints. Yes, cost is always a constraint, but simply writing cost is no use. You must say cost should not be more than 3,000 rupees for a 100 liters per day capacity. If I build a 200 liters per day capacity, then cost can be double, no problem. Yeah. So something like we have to define. Those are the constraints. And yeah, pass or fail will actually come closely aligned to whatever we discussed before this. What will make the person accept it or not accept it? It has to be specific. It has to be like test. The answer to each of these should be yes or no. Okay. So it has to be very sharply defined. The precision in definition is very important because there is a guideline for the design. If you notice, though we have done it in the other order, in the reverse order, we have first designed something and now we are trying to make the document. Normally the document is made first and then only the design starts. So for design, there should be a guide. It should be a guidance for how the design should go about. And then of course the system architecture will flow from that. And you seem to have built something which is 1 meter by about half meter by half meter. Okay. And you're not mentioned how heavy it is, how heavy the empty object is, and probably it will have water inside it. Then it will become heavier. All of that. And that's fine. Otherwise, the rest of the thing is no problem. Again, in this project plan, this is all very generic. You have to be very, very specific here. The project plan is a guide to design engineers, to the engineers in the design, to say what they should do, when they should do, what they should be alert for, what they should be careful about, etc., etc. So that's it. So this is fine. So let me stop the sharing. I suppose we are just on time, but I can take any questions that you may have. Did you get the idea of what we discussed? I'm not asking you to change the work you're doing, but I'm trying to ask you to fit the same work in a different framework so that the solution you make is aimed at a specific user whose life will benefit from your solution. Otherwise, you will be making something as a hobby because it is interesting for you. And after you finish making it, you will show it to a few friends, and then it will simply be in one corner. It won't improve anybody's life. Whereas if you put it through a framework like what we have been discussing, then if you build something that is useful, actually somebody can take it up. Of course, what you build may not be very good, but that's always true. When I build something first time, it will not be very good. I have to do it 2 or 3 times before it meets all the requirements. But at least I know the direction. This is the user, this is the price, this is the performance, this is the quality. So I am now there 40%. Maybe if I do it one more time, I'll become 75%. And then once more I do, it will become 95%. Nothing will be perfect. And then at that point, it will become a product and that person will take it and use it and benefit from it. And when a person benefits from it, that person will be willing to pay me for it. So I will also benefit. So that's the whole idea. It is not to ask you to do some different project. So are there any other questions?
Students?
Sir?
Yeah.
Sir, what if we are not getting a desired output, sir? For example, we are trying everything we could, sir, but not getting that kind of output we want. How to proceed further, sir?
No, that is normal. See, even when ISRO tries to launch a rocket into space or put a rover on the Mars or anything like that, they will not always succeed. See, succeeding is a different matter. But what do I want to do? That goal must be clear. In fact, when you say we are not succeeding, it actually means that you are clear about the goal. If I'm an athlete and I say I want to jump 5 meters in long jump, that means my goal is clear. If I'm playing cricket and say I want to score at least 200 runs, my team should score 200 runs, then the goal is clear. I may not score 200 runs. I may not jump 5 meters. Then I have to try again. I have to practice again. And I can do it multiple times. So that is part of life. But if I don't even know what is the length I should jump, if I don't even know how many runs I should try to score, then that is not good. So that is why you have to set those metrics in place even before you get into the design.
Sir, if we are being very specific with the design, sir, but at last, we are completely failing at somewhere in some point, sir, but we don't know where we are really making the mistakes, sir. So we are not getting to that point what we really need, sir. So
that is true. So no problem. We can then review. See, for example, if you were to say that using a punching bag's energy, you will pump up all the water to the overhead tank, which is needed for the shower in the gym. Then very clearly, just by using normal arithmetic, we will be able to see that the energy needed to pump, say, 100 liters of water to the water tank is thousands of times more than the energy that is recoverable from the punching bag. So we will straight away say that this will not even work. We don't have to spend a lot of time and energy to try to build something and then find that, oh, I'm not able to do anything more than charge 2 cell phones. Right? At the beginning, we will be able to save a lot of time and effort in not doing something which is not possible to do. Okay. So if we have clarity about the problem we are trying to solve, we can move in a more targeted way towards it. I'm not saying we will always succeed. And again, there is nothing called full success or full failure in design. Just like I said, nothing is wrong or right. We will come closer to our goal. But how close we come is not always in our hands. It depends upon our efforts, our competence. It also depends on a number of environmental factors. And it also depends on the experience and various other things. But when we learn from it, in the second effort, we'll come much closer. In the third effort, we'll come still closer. So this is a fact of life.
Thank you, sir.
Yeah. So if there are no other questions, yeah.
Thank you, sir. So even in your busy schedule, you patiently are explaining each and every words what actually gave us a statement submitted by our teams. And with a lot of real-time examples, you are giving the inputs to the students. That is really nice, sir. Because usually students correlate the things, they are taking the things as just engineering. Now they come to know how to develop a product for a society. So with the societal aspects, you are explaining each and everything. Hope this session is very useful for us too, for a staff.
You must make build all the products you're trying to do, but you have to imagine who will benefit from it. Then you have a product.
Yes, sir. Sure.
That's what the whole exercise is about.
And I too saw a lot of changes in our team, because while I interact with our students, all the 5 teams, they are nicely designed the product and they are nicely trying. That Vivek team and all, many times even they failed to get the output. They are trying again and again with staff by studying something. So yes. It's actually because of this leap only. Really, I thank you and our Jagdish sir, Vaayusastra team. Thank you, sir. Thanks a lot.
Thank you.
Thank you. Thank you very much. Yeah.
Thank you, Professor. Kavitha here.
Yes. How are you doing?
Yeah, fine, sir. How about you?
Great. Doing very well. Yeah.
Yes, sir. Yes, sir. Sir, great. Actually, the inputs which we are getting from your side is changing the dimension of our thinking of a student, sir. So that is what we wanted, because
Okay.
otherwise they will be like they will have a product and they will be searching for launching it. But we want what is needed for the as a solution. So as a solution for a problem. So thank you for that dimensions, and we are also learning a lot, sir. Thank you so much, and
Thank you. It's my pleasure. Yeah. Thank you very much.
Thank you, Jagdish, sir.
Yes, sir.
Yeah.
Thank you.
Thank you, Professor. Thank you very much.
ஓகே, நான் என் பண்றேன். ரெக்கார்டிங் என் பண்ணா என்ன ஆகுது பார்க்கலாம்.